Good afternoon, everyone. Today we'll continue Newton's method. Uh, we need also to make a quizzes.
Afternoon.
We need also to make a quizzes very soon. So please make a WhatsApp group so we discuss the time that is good for all of you. Make a group and send the link here so we all join. Okay.
Okay, I would make it.
Okay. Thank you. Now let's solve again the cosine example. Find correct to 6 decimal places the solution of the equation cosine x equals x. Last time we started, but we didn't have enough time to complete it, so let's solve it again. So let's start. Now you can find x1 using the graph of cosine x and x. But before that, let's write the formula. Remember the formula is this one. Xn plus 1 equals xn minus fxn over f prime xn. To start using Newton's method, we need to find x1, right? We also need the function. But before that, let's find x1. You can you can find it using the graph. Here is the graph of cosine. Next, let's draw the graph of x. So here you have y equals x. Here you have y equals cosine x. What's the x value here? Pi over 2, right? Nearly 1.57. What is your estimate for the solution? The solution is the intersection point, right? So what's the x value here?
Pi over 4.
It's close to pi over 4. Pi over 4 nearly 0.78, right? If you want, you can write 5. This is very precise. So, so if you want, you can choose x1 equals this value or 0.7 or x1 equals 1. I prefer 1 because 1 is easier, it's integer and better. But any number of these you can choose it, okay? Because they are close to the solution. But this number and also 0.7, they are very close to the solution. I mean 7 is correct in the solution. Now if you
Hassan,
yes,
I created the group and it's on in the chat box.
yeah, thank you.
No problem.
We will make a quiz for mean value theorem and also one for Newton's method.
Newton's method is which chapter exactly?
Section 4.8.
4.8, okay.
So let's continue. Now here, if you don't want to find x1 using the graph, what can you do? You can use intermediate value theorem, right? Let me remind you the mean, I mean the intermediate value theorem. So let f be continuous on the closed interval AB, and f of A less than f of B, then what? Uh, f n greater than f of A less than f of B. So here f of A, here f of B. Then there is C belongs to open interval AB such that f of C equals n, right? Now what's the function here in our example? See the equation, cosine x equals x. I can take it x minus cosine x, or cosine x minus x equals 0. So the function f of x equals this, or f of x equals this. You decide. Me, I want x minus cosine x, but if you want the other one, as you like. Now, if I want to see where is the solution, I want 0 greater than f of A less than f of B, right? I want f of A to be negative number. I want to substitute A such that f of A will be negative. And also, I want B such that f of B is positive. Good? What's your suggestion here? What is good choice for A, for example? What do you think? Do you hear me?
Yes, we can hear you.
Do you have suggestion for the value of A? 0, for example, right? F of 0. What's the result of f of 0? 0?
-1.
Yes. So 0 minus cosine 0. 0 is 0. Cosine 0 is 1. So minus 1. So this is good. For B, what do you suggest?
I think we can use 1.
Yes, 1 is good. So f of 1 equals 1 minus cosine 1. You know that cosine 1 is between 0 and 1, right?
Yes.
Because 1 radian is in the first quadrant. It's less than 90 degrees and greater than 0 degrees. So we know its value is between 0 and 1. So this value is positive. 1 minus cosine 1 is positive. So our solution will be between A equals 0 and B equals 1. So we can وعليكم السلام. So we can choose x1 equals 1. Good. Do you have question about this? Okay, let's continue. So we have xn plus 1 equals xn minus fxn over f prime xn. Next, what do we need next? Uh,
Derivative.
yes. So f of x. Um, I will write the second line. F of x equals x minus cosine x. What's the derivative? 1?
1 plus sine x.
Yes. Thank you. So here this equals xn minus xn minus cosine xn over 1 plus sine xn. Now let's start with x1 equals 1. Now x2 equals x1. So let's use the calculator now and make sure that your calculator is what? Radians, okay?
Yes.
So let's start. We have 1 minus open parentheses, then 1 minus 1 cosine, then close the parentheses, divided by open the parentheses 1 plus 1 sine, close the parentheses. You get, where is it? You get this number, 0.750363. Is one here correct digit? No, right? Because it's here 0. Next, is this 7 correct? We don't know yet. We need to find x3. If it's still 7 in x3, then 7 is correct. So x3 now, in your calculator, you write like this: answer minus cosine answer over 1 plus sine answer. And same with x4. You write answer minus, same idea, okay? Me, I will use Control C and Control V. See here, we want it correct to 6 decimal places. So you need to find more values until you have 6 digits correct. Control C, Control V, minus, open parentheses, Control V, minus, Control V cosine, close the parentheses, divide, open parentheses, 1 plus, Control V sine, close the parentheses, you get this number. Yes, it's correct. What are the correct digits now?
0.7.
Yes, thank you. So these are correct. Now x4. x4. Now again, Control C, Control V, minus, open parentheses, Control V, minus, no, again, Control, I didn't copy, it's a problem like this. Yes, I want this number, right? Yes, it's good now. So this number minus open parentheses, control V minus control V cosine, close, then divide, open, 1 plus control V sine, close, you get this number. What are the correct digits now?
0.739.
Yes, thank you. We still need more 3 digits. X5. Now, control C, control V minus, open, control V minus, control V cosine, close, divide, open, 1 plus control V sine. So we get 0.739085. We have correct to 6 decimal places now, right?
Yes.
So we stop here. For this one, it's good like this. Now, see here. Show students the beauty of dotty number. This number here, the solution of this equation, cosine x equals x, is called dotty number. Okay? It has a very interesting property. You will like it. I will show it to you now. So remember, this is the value, right? 0.739085. And here it tells you that even 1 and 3 are also correct. So remember this. Choose any number you want.
500.
Okay. Keep applying cosine, 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 cosine. Do you see?
Yes, it's approaching the value.
Yeah. So if you want, you can choose any number if you want. Choose another one.
Yeah, can you explain why that is, or is it too complicated for us?
I will tell you about that, but let's choose another number first. Another one.
Negative 13.
Negative
13.
13. Yes. Keep applying cosine now. So I will tell you now about it. This property is called, but before that, when you have this thing, f of x equals x, you call this fixed point. Fixed point because the input is the same as the result, as the output, okay? So you call this fixed point. Fixed point. The type of this fixed point, it's called globally fixed attraction point. Globally means that you can choose any real number you want. When you keep applying cosine, the result will be attracted to the solution. I think I downloaded a PDF file paper, I think, about this thing, but I don't remember all the details now. So, but and also I want to tell you that there is another method of solving equations. It's called the fixed point. No, not fixed point. Uh, yes, I think it's called the fixed point method. So, but forget about this now because it's not included with you. But I wanted to show you this nice property. And unfortunately now I don't remember the details about this, so I can't give a complete answer. But it's called globally fixed attraction point. Let's continue now. Now see this. This graphic question is for understanding. So the figure shows the graph of a function f. Suppose that Newton's method is used to approximate the solution S of the equation f of x equals 0 with initial approximation x1 equals 6. So see here. The solution is S. You start with x1. x1 is 6. You draw the tangent line, this one. Then the intersection with the x-axis is x2. You remember this idea, right? That the idea of Newton's method, that you start with x1, you draw the tangent line, then x2 will be the intersection, then you draw the tangent line of x2, the intersection is x3. Okay? When we estimate these values, they are here. x1, we started with x1 6, x2 is 7.5, x3 is 7.1. What's your estimate for the solution? Nearly 6.7, right? Next, see the other part. The other part starts with x1 equals 8. So here, you have 8 here. Draw the tangent line. It's the green one, okay? You get nearly 7.3. I considered at 7.4 before. Then 7.4, draw the tangent line. It will be the red one, okay? The red one, then intersection here. I considered at 7, nearly 7. So which one is better? x1 equals 6 or 8? See here, S is nearly 6.7. When we tried x1 equals 6, we get 7.1 at x3. The other one, we get 7. 7 is closer to the solution, right? So for this equation, x1 equals 8 is better. But do you see something strange here? That here, 8 gives you better approximation, faster, see here, faster than x1 equals 6, even though 6 is closer to the solution. See here, which one is closer, 6 or 8? 6, right? So this is the idea of this equation, that it tells you it's not necessarily that if you choose the point closer to the solution that it will converge faster. It's better to choose closer, but this question tells you that it's not necessary that you will have it faster. Good. Now let's solve this one. Do you have questions? Zidane,
Yes, Professor.
I need your help with this problem here.
Okay.
So, what's the function here? This.
Sorry, one second. I can't see your screen. One second.
Good. Are you ready now?
Just a minute. Just a second.
Yeah. Okay.
Okay, I can see it now.
Okay. The
So you have to find
equation
f
tells
dash x, right? So it's
y-
gonna be 6x squared minus 6x.
let's start with f of x. F of x equals 2x cubed. What's the problem with this?
Yeah, yeah.
So 2x cubed minus 3x squared plus 2. So f prime of x.
No, the derivative it's 6x squared minus 6x.
Yes, thank you.
Yeah.
Now the formula xn minus fxn over f prime xn. Then substitute, you get xn minus 2xn cubed minus 3xn squared plus 2 over, you substitute in the derivative, you get 6xn squared minus 6xn. x1 is already given,
Yep.
so x1 equals minus 1, and the question tells you find up to x3. So
Yeah.
x2 equals, now we'll use the calculator. Where is that?
You just have to substitute now, right?
Yes, thank you. Now, there is something important here. This is negative number here, minus 1, right? You need to put parentheses around the negative number, because minus 1 is squared. For example, here you have xn squared, right? Minus 1 squared is 1, right? But if you write without parentheses, you get minus 1 squared is what? Minus 1, right?
Yep.
So when you substitute in your calculator, you need to put parentheses around the negative number. Let's do it.
Yeah.
So minus 1 minus, open parentheses, 2 times, open parentheses, minus 1, close, power cubed, then minus 3 times, open parentheses, minus 1 squared, then plus 2, close, then divide, open, 6 times minus 1 squared, then minus 6 times, open parentheses, minus 1, close, 2 times. Now we get the result, minus 0.75. Now x3, same idea, we need to put parentheses around it.
So you just have to substitute.
Yeah, Control C. Now Control V minus, open, 2 times, Control V cubed minus 3 times, open, Control V, close the parentheses, squared, then plus 2, close, divide, open parentheses, 6 times, open parentheses, Control V, then close, squared, minus 6 times, open, Control V, close twice. You get this number, minus 0.682539.
Yep.
Yes, it's correct. Thank you, Zidan.
Welcome.
Here we are not sure what are the correct digits, right? 7 is not correct, clearly. What about 6? We don't know. We need to find more if we want to know whether 6 is correct. But I think it's correct. But here this question tells you just find up to x3. So no need to know what's the accuracy here. Let's go to the next one now. Yeah, it's correct. Now this one is important. David?
Hello, can you hear me now?
Yeah.
Okay.
Please help me with this problem here. Using Newton's method to approximate the given number correct to 8 decimal places. Fourth root of 75. What do you think?
Okay, so first, uh, it's to the power 4, right? Or to the fourth root?
You want like this?
Uh, no, I'm asking, yeah.
So, so you suggest this function. Fourth root of x. The method would work, but I have criticism for this method. My objection to this that when you want to apply the Newton's method, then if you use this function, it will involve like this, right? Xn minus fourth root of xn, also the derivative here. So you will calculate fourth root of numbers that even they are harder than 75. Okay?
Yeah, I see the issue now.
You can use this function, but I mean, it doesn't. Uh, it's not good for the idea, but it works if you use this function. So, what do you have another suggestion here about this function? What what should it be?
Ins- Instead of f of x being equal to the fourth root, is it possible to rewrite that into a different way to get it to a simpler, more like
Yes.
condensed way?
So so you start x equals fourth root of 75. Then power 4 both sides. You get x to 4 equals 75. Then minus 75 both sides. X to 4 minus 75. Is this a good function?
Yeah, it's a lot simpler.
Yeah. So f of x equals this function. Now, what's f prime of x? 4x
f
cubed.
prime is 4x to the power 4.
Yeah. Now, the formula xn plus 1 equals xn minus f of xn over f prime xn. Substitute, you get, let's substitute it here. So xn minus xn to 4 minus 75 over
Over
4xn
xn
cubed.
to the power 3.
Yeah. Now I have a suggestion here, but as you like, whether you want to do it or not. You can make common denominator and add them to make it easier when you substitute in the calculator. Okay. So you get multiply here 4xn squared over 4xn squared. You get sorry, I mean 4xn cubed over 4xn cubed. So you get 4xn to 4 minus xn to 4, so minus xn to 4 plus 75. So plus 75 over 4xn cubed. This 3xn power 4, right?
Yes.
We still need to find x1. What's your suggestion here?
x1, would we not simply try to move around the denominator? Or no?
No, I mean to start the method, you need x1, right?
Yeah.
I will tell you how to find it. You will use the intermediate value theorem. Now we want this to equal 0, right? Okay.
Yes.
So you want to find 0 greater than f of a less than f of b. Good. You want this negative number, this positive number. What's your suggestion for a?
Take 1.
Okay.
Does it have to be starting 0? No, it cannot.
Yes, it's good. 1 is good. So 1 minus 75 negative, right? Good. Now b, what's your suggestion for b?
76 maybe? Make it to get a positive.
No, here you have power 4. So choose the small number. 3 is good. So f of 3 equals 81. 3 power 4 is 81. Minus 75, 6. Positive, right?
Yes.
Now here, this number is very negative, right? So if you want, you can choose 2. f of 2 equals 2 power 4, 16. Minus 75 equals minus 59. Okay? So the solution is between 2 and 3. See here, 2 and 3. It's better than between 1 and 3 because you have more choices between and 3 than between 2 and 3, right?
Yeah.
What do you think? I want to choose one between 3 and 2. Which one is better?
Any number between 2.5?
No,
That'd be 2.
yes, 2.5 is good. But I mean, choose between 3 and 2. I want to choose one of them. Which one is better? What do you think?
3?
Why 3?
Because it's closer to the 0.
Yes, you are right. The value is 6, right? When you substitute 3, 6 is closer to 0 than minus 59 when you substitute 2. So you are right. 3 is better. Thank you. Now we will erase this to choose a 3, okay? Are you good with this idea? To find okay. This idea is very important. I will ask about it in the quiz for Newton's method. And if you want, we can make it harder than this example to enjoy it as you like.
No, no, no.
No need harder.
Let's make it easier.
Yeah. I don't know why you want it easier, even though you are smart. You are smart students. You are solving
No,
with
but
me.
you can do the hard ones for fun, but in the quiz it should always be easy.
Yeah. If I put it as bonus, then I'm free, right? To put it, right?
Then it's fine.
Yeah. Now let's start. So we have x1 equals 3, then x2 equals, we need to use the calculator. So 3, 4. See, remember, just 1 second. This equals 3x into 4 plus 75 over 4xn cubed. Good?
Yes.
So, open parentheses, 3 times 3 power 4 plus 75 close divide 4 times 3 power 3. Close. You get this. For repeating. What are the correct digits now? Is it clear or not yet?
Yeah, it is clear.
2 is correct, right? We know 2 is correct because we know the solution is between 2 and the 3. So if it's not the 3, then 2 is the correct one. Let's continue now. x3. Now Control C, then open parentheses. 3 times Control V power 4 plus 75 close divide open 4 times Control V cubed close. You get this. What are the correct digits now?
2.94.
Yes, thank you. So 9. Now x4. Control C. Now close. Then 3 times Control V power 4 plus 75 close divide 4 times Control V close. You get this. And it's clearly not correct, right? Because I forgot power 3. Let's do it again. So open, then 3 times Control V power 4, then plus 75 close divide open 4 times Control V power 3 close. You get this number. What are the correct digits now?
Until 283.
Yes, thank you. So look at the right of the decimal point. We have 5 correct, right? So we still need more 3 digits. Good? x5. Now Control C, open 3 times Control V power 4 plus 75 close divide open 4 times Control V cubed close. You get this. We are done, right?
Yes, we have 8.
Yeah. If you want, you can find the value using your calculator. 75 power 0.25. So they are correct. 8 digits. What do you think about this method? Is it easy?
It's nice. I
Ye-
like it.
Yeah. And it even can be done by hand. If you choose easy value for x1. You may ask me what about the others, right? Because they are complicated. Yes, they are complicated, but you can write it as a function. It will take you a few hours or few days to reach x5, but it can be done by hand. But we wouldn't do it, right? Now, I didn't call you. I was choosing arbitrarily. Uh, there were ones who joined lately. Okay, you need to join at the start of the lecture. Okay, and I think there were ones who sent me that they will not be able of joining. I will include your names in the attendance. Okay, since you have exam, I think. Do you have questions?
Yes, when is the next quiz?
We will discuss it. Did you join the WhatsApp group?
Yeah.
We will discuss the best time for all of you.
Okay, and it's about Newton's law and
No,
mean value theorem.
the first quiz mean value theorem. The second one will be Newton's method.
Professor, when is this quiz?
What?
When is the quiz?
We didn't decide yet. See the WhatsApp group link here. Join and we will discuss it.
Can you put it again in the chat? Because I didn't join it. I joined like 5 minutes after that.
Okay. Ah, it didn't appear for you.
Yeah.
Just 1 second. Can someone send the link again because it's not working?
It's in already.
Okay. I need to break my laptop, right? Because now let's take the names. We finish here, and thank you all. Have a nice day, and you can leave if you want.
Thank you,
Well,
Professor.
thank
You're
you very
welcome.
much. Have a nice day.
Thank you.